Hi, welcome to the next installment of Quarter 4 Review. We have the last video of the series is going to be about organic reactions. So we're quickly going to go through all the different organic reactions and what you need to know. First of all, combustion. Combustion, now you know this word hydrocarbon. Starts with a hydrocarbon. It could also be a sugar. It can contain oxygen in it. It just has to be a hydrocarbon or some kind of carbon compound that's reacting with oxygen to produce carbon dioxide and water. Now, if there's sufficient or excess oxygen, then you're going to get carbon dioxide, 2 oxygens. If there's insufficient oxygen, meaning not enough, you're going to end up with carbon monoxide, not carbon dioxide. Notice sufficient oxygen, carbon dioxide, insufficient oxygen, carbon monoxide. Again, combustion, you have a hydrocarbon reacting with oxygen to produce carbon dioxide and water or carbon monoxide and water. Next, we have fermentation. Remember, we talked about bread as far as a very good visual for fermentation, because fermentation is when yeast undergo anaerobic respiration, where they break down sugar using the enzyme zymase to produce both an alcohol and carbon dioxide. You know, if you've ever baked bread, that sometimes it smells a little bit like alcohol when you are letting the dough rise, and also that the reason you let the dough rise is because there's going to be a buildup of carbon dioxide, so that's what gives you the air bubbles in your bread. So again, if you have glucose, it's reacting with the yeast are actually fermenting the sugar. Again, there's that word, fermenting the sugar. Without oxygen present, it's anaerobic to produce alcohol and carbon dioxide. Alcohol and carbon dioxide. The bread dough smells like alcohol and it produces carbon dioxide. That's what causes it to rise. Next, we have a substitution reaction. Substitution is when you have a saturated hydrocarbon. Remember, saturated is all single bonds. Say it SS with the saturated single bonds. And what happens is this is just like being on a ball field. All of the bonds, all of the carbon atoms are saturated with hydrogens. In other words, there's no space to add any more atoms. But it's reacting with bromine, so where is the bromine going to fit on the molecule? Well, in order for one of the bromine atoms to react with this hydrocarbon, what has to happen is it has to substitute for one of the hydrogens on the saturated alkane. And then that hydrogen goes back, what we call on the bench, and sits with the bromine. So let's do that one more time. This is substitution. Think about a ball game. You have a full field. It's a saturated hydrocarbon. In order for the bromine to react, you have bromine is a diatomic. One of the bromine atoms is going to substitute in for one of the hydrogens on the alkane. The hydrogen is going to then come sit on the bench next to the bromine. So if you look at the products, you get HBr, and also you get a halocarbon where you have the bromine substituted in for one of the hydrogens. That's different from addition. Addition, you start with an unsaturated hydrocarbon. Unsaturated meaning it has a double or a triple bond. That means that that double bond or triple bond can break and you can add more atoms. So in this case, the double bond breaks and you add bromine atoms. Look over here at the product. You have one product in addition. One product. The two things combine to form one. That's different. Go back to substitution. You start with two products and you start with two reactants and you end up with two products. That's substitution, but addition, you add them together to get only one product. See, the double bond broke and you get the bromines added on. Hydrogenation is just a special type of an addition reaction where you're adding hydrogen to the molecule. Esterification. This one's really important. Remember Aunt Esther. Here she is right in the middle of the molecule. You're producing an ester. This is on table R. Now, what's really important that you realize is that an acid and an acid and an alcohol come together. So you see an acid and an alcohol. This is an alcohol come together to make the ester. So how can you tell which part is the acid and which part is the alcohol? Well, it breaks. If you break the ester right where the ester functional group is and you separate the pieces, the piece that's attached to the ester, in this case it has 2 carbons, and see it's attached to this carbonyl group which has the double bond to the O and attached to the other O, that becomes the acid. Look, let's count 1, 2. 1, 2. This is the acid over here. This is the acid. And then on the other side, this piece becomes the alcohol. Notice there's only 1 carbon. Here's 1 carbon over here, and it becomes an alcohol. Okay? Again, this is called esterification. The acid and the alcohol react to yield methyl ethanoate in this case, which is an ester, and water. We pull the water out of the reactant in order to get the products and smush them together. Saponification. Don't you love that word? Say it 3 times fast. Saponification, saponification, saponification. Love that word. What is it? It's just the making of soap. In the making of soap, you should realize that it starts with an ester or some type of fat, reacts with a base, NaOH, to produce an alcohol, glycerol usually, and a soap, which is an organic salt. It's very important that you know that the name of this reaction is called saponification. Finally, the last type of reaction is called polymerization. Anytime that a question asks you about a long chain that's formed, that's a polymer. Polymer means, poly means many. Many short units or many monomers put together makes a polymer. So a polymer is a very large molecule formed from many smaller repeating units. Again, there are 2 types. There's a condensation polymerization. Condensation polymerization happens the exact same way as esterification happens. All you need to do is remove a water molecule. So do you see here, if you have 2 alcohol groups on the 2 monomers, cross out the water, actually physically cross it out, and then smush the remaining parts of the molecule together, and you will end up with kind of looks like an ether bridge, right there. Okay, and of course you have water left over because it's condensation. The last type is called addition polymerization. Again, very similar to addition. It starts with unsaturated hydrocarbons, and the double bonds break and allows the carbons to form in a long chain. So the double bonds break to form single bonds, and you get long chains of repeating units. This is addition because you have the double bonds breaking and adding together. The one thing you might see is you have the N written as a coefficient. Sometimes the notation is, so when it's monomers, the notation is that the N is written as a coefficient, but then when it becomes a polymer, the N is then the subscript, meaning that this molecule is all joined together. I hope this helps. Good luck. Bye.